Hello and good morning, and thank you so much for joining me here. Today is July 20th. Been a couple of days since I've been in my shop. I've been busy doing other stuff, and the weather's been so fantastic here. Not so fantastic today though. Kind of gray and rainy outside, but supposedly sun is coming. So, the last thing I did was I removed this from the radio and began examining it. And I noted when I put in screwdrivers and grind around in here, it comes out with black powder on it. You can even see it on my finger there. So this is really kind of weird. The other slug that was in this was a metal slug. This one looks like a metal slug when I look at it. And I'm having trouble moving it still. So when I look at the other transformer, it appears to have metal slugs in it, but it's hard to say, looking down from the top, just exactly what's down there. I could try installing a different transformer, because I do have replacements. Genuine Admiral parts here, brand new. Well, still in the bag. It's not exactly brand new. These look quite suitable. Interestingly enough, on here, one terminal is marked with a green dot, and the same thing is true here. The green mark. Would that be the same terminal? Is that a standard sort of thing? That's kind of weird. What's inside there? So, I have no reason to think these are no good. That's a possibility. But these other ones I have, well, like this one, this has come out of somewhere, so I don't know that. Oh, I do know the condition of this one. These other ones have six leads on them. I'm not exactly sure what's going on there. This bag, it does give a capacitance, 107 picofarads, C1 and C2. That's probably the two capacitors inside here for the primary and the secondary. You're on my keyboard, man. Here he is. So the question boils down to, should I attempt to make this work on the basis that if this works, it's probably better for the radio, if I can make this work properly? If there's really nothing wrong with this, just get the slug in the right spot, we're done? Or just skip to trying one of these and save myself the terror. What do you say? What do you say, buddy? Should we fool around with the fool around thing, or go with the supposed certain thing? But we don't even know how certain this really is. Okay, I'm gonna take a few minutes to think about this and try to figure out the best way forward. Okay, still trying to make a decision here of what to do. I really haven't thought this one through 100%. It's got clips on the side, but you can see the height of them is totally different. A different kind of clip than this one. So if I were to install this, how would I support it in the radio? Perhaps just by the wires down here, just holding it by the leads. That's not too good. Does it even fit? I don't even know if it fits. Would not have to be installed up above. Well, it fits quite nicely. But the bracket, I wonder if it's some kind of universal bracket. What are the chances of that? what are the chances of me finding the bracket? Where is the bracket? There it is. This would go... Oh, look. It does have the same. Yeah. This would snap in. There we go. We're going for this one. Now the next issue is, although this is marked with green paint and so is this, are they the same thing, really? So with this one, I can actually look at the wires. I can see what's hooked up to what. Plus, we know from looking in the schematic and other things what's what. This one, it's not marked other than the green dot. It comes with instructions. Yeah, it's a big piece of paper here. It's gonna have a diagram. Sure enough. So there it is. 1, 2, 3, 4. Shows 1, 2, 3, 4 what they are connected to. This is perfect. These transformers are designed for use in either input or output stages. I don't know what they mean by that. Coil Manufacturing Limited, 50 Wingold Avenue, Toronto. I've never heard of Wingold Avenue, Toronto. I used to know pretty much every road in Toronto. Well, there we are. Well, it even comes out and says what they are. Terminal 1 goes to the grid. Terminal 2 is for AVC. Terminal 3 is for the plate. And Terminal 4 is a B+. Which one is marked with the green? Assumably number 1. That's probably a good assumption. Number 1 is marked with the green, but they didn't mark it on here. They did not put it on there. What is this diagram? Don't know what this is. Okay, I'm reassured to try this, but I'm going to give it some more time to think. Took me a long time to get this set up on my screen here because I forgot I turned off my keyboard, because I turn it off now because of the cat. The keyboard's off. You can't do much with your computer when the keyboard's shut off. So anyway, here we are. We can compare this to the diagram up above. So if we assume the green dot is number 1, obviously that's the case with the radio, but the green dot is marking number 1 on the replacement coil. We'll assume that's the case. So in that case, 1 down below, oops, I gotta move this up just a little bit here. Because we have to look at these numbers here. So if we look at this, okay, surprising to me, 1 is not on the primary side. 1 and 2, I'm looking at the radio now, down here. 1 and 2 form the secondary side. Now if we look up above, 1 and 2 appear to form the primary side. It doesn't really say primary and secondary, does it? And maybe there isn't. Maybe these are identical coils. The one that came out of the radio that I've got the cover off, the coils look identical. And that could easily be the case. Then you'd expect the capacitors to be the same size too. C1 and C2 on the replacement is the same size, 107 picofarads. So probably there's no primary and secondary to really worry about here. What you really have to worry about is you get the 1 and 2 correct. You don't hook up across the transformer by accident. Okay, so that means I put the transformer in place. I look at the green dot. I know the green dot is marking number 1. Number 1 in the radio is the secondary side. Number 1 in the replacement, we don't know. In fact, we don't really know either of these two transformers. There is no real secondary primary, although on the existing one we don't know that the two capacitors are the same. You can assume they're the same. Same size coil, probably same capacitor. Same is easy to construct, or easier to construct too, from a manufacturing point of view. So if I pop the coil in, and another issue here is a phase change, where if you look at the schematic and you see the terminals 1 and 2, what would happen if I reverse those? If I flip those connections around, so the signal is inverted 180 degrees. That's going to cause a big problem, is it? I don't know. I don't know if it will. How do you avoid that? Well, let's see. On the radio, terminals 1 and 3 are at the top, so to speak. And on the replacement, it's 3 and 2, or 1 and 4. I don't know if this is helping me at all or just causing confusion. And I like to spend time thinking about stuff because it takes a while for my brain to put the pieces together, and I got to give it a chance. And I may not even know what the pieces are. Yes, what do you want? You want to play around? Apparently Bert wants to play around. It's a good time for me to stop right now and think a bit. Okay, I've got my ohm meter here, and I just want to convince myself that starting with the green one. You gotta be kidding me. Let's try this again. Let me test my meter. Okay. There we are. So if this is 1, then this must be 2 on this diagram. And this can only go in this way or this way. So let's say we put it in this way. This one, son of a gun, I don't remember how this was in. Green dot is there. I think it was this way, but I really don't remember. Assuming it's this way, then I can see that these two are going to the top coil. So if it were in this way, these two, put this in, okay, so I'm going to fiddle with this for quite a while on my own here, because there's going to be a lot of silence while I think this through. I find these things really, really confusing. Okay, I was smart enough to take a photo of that before I took this part out, so I know the green dot was positioned the way I have it now up at this corner. Now I want to find out absolutely where these coils are. There. Okay, so if this is in like this, number 1, or the green dot coil, the number 1 coil is between here and here. So it'd be the same thing with if I put this in this way. The problem is the clip is designed this way. So that's really a big annoyance here. So that means if I put this in and rotate it in order to operate the clip properly, it will rotate all the terminals. So what went in this corner now has to come down to this corner. And all these wires are just long enough to go back to where they were. Have I really got this right? Because I didn't want to get this wrong. Let's look at this again. So it would certainly look like the clip comes across like this. Put it in like that. The clip would come. Oh, that can't work. Yeah, I'm misinterpreting the clip. Yes, I'm misinterpreting the clip position. That's what I'm doing. And it's microphone time this morning. Go for it, buddy. Okay, so the clip is the other way. So that really does solve the problem. So then if I go ahead and put it in exactly the same. That's what it comes down to. Put it in exactly the same. Green here, coil here, coil here, coil here, coil here. Let's put it in just like that. And wait a minute. Have I got the clip thing right? Can the clip go in this way? This radio is still not on, but look at the other can. Oh, definitely. Okay, so we would want to, I guess this didn't come with a clip. It's a replacement, so I guess they're anticipating there's a clip here. So we're coming in just like this. I'm going to jam this clip in. What are you doing up there? Oh, you're still watching up above. Watching my cat. Okay. Actually, what I'm doing is more interesting. So I'm about to push the clip through. Okay, now will this actually clip? That's a good question. Yes, it will. It's on one side now. Well, maybe with some effort. Okay, let's not lock it in too tight because things can go wrong. I have to take it out again. So I think my best move is to solder all the wires on the same positions they were in before. Everything seems to work out that way. And we'll see if the radio works at all. That's the primary thing. Okay, so I'm going to solder all those wires in. Good luck. Okay, I've got it wired up. Now, I think I want to just consider, what if I've made a mistake? How can I detect a mistake before it's too late? Is it too late? The mistake would be, like, the dangerous thing in here is the B plus connection. The B plus connection, if we look at the schematic, just give me one moment here. So B plus is connected to pin number 4. Pin number 4, which is opposite pin 1 on this diagram. Opposite pin 4, opposite pin 1. So we have pin 3 opposite pin 1. Ooh, wow, that means we might be turning the that's another issue here, is the output from the transformer, if I do this backwards, will be 180 degrees out of phase, continue through the radio out of phase. Is that a problem? I'm not even sure. So what if so the positive, the high voltage lead rather, is coming to pin number 4. Pin number 4, if I count these right, is 1 clockwise from green. Clockwise from green. 1, 2, 3, 4. So this would be the one with B plus on it. It also has, just to verify, a resistor and a green wire leaving it. If I look at pin 4 on here, we see, sure, there's a capacitor. There's a resistor, a 1K resistor. Is that what this is? Yeah, this is a 1K resistor. So bingo. So this is the primary. In my thinking, this is connected over here to this pin. Oh my God, I'm not going to be able to sort this out. lose my mind doing this. So in this transformer, oh my God, I don't want one. I'm all turned around here. 1, 2, 1, 2. I don't know if this is right. Okay, another way of looking at this. If I've done this wrong and I turn it on, what bad thing could happen? Let's just take a look at the schematic together and ponder this before I make a big mistake here. Okay, still got the camera on there. Okay, so we are looking at the first IF. So it's this one over here. And this is the positive. This is the B plus coming in. Now what would happen if I connected it here by accident? So B plus sitting here now. Okay, B plus on this grid, not a good thing. Not a good thing. And B plus would then come down through here. And it's going to encounter its capacitor. That's not a problem. And this great big resistor, that's not really going to be a problem either, I think. And then we're in through the heaters. Oh my God, you know what can happen here is I make a little mistake and burn out all the heaters on this radio all at once. Oh my gosh, I better be super cautious here and really be sure of what I'm doing. And I am not at this point, so I do not have the good feeling. Coffee time. Okay, I've given this a little bit of thought. I'm quite anxious about this. So one approach I could take is to artificially supply B plus at a very low voltage into the radio without the radio operating, and then measure the B plus and find out where it is on here. And could do this with 10 volts or something like that, and wouldn't really risk too much. That's one approach I can take. The other one is just a careful examination of the situation here. Eyeballs won't do much help now. I've sort of eyeballed it as far as I can. It's making some measurements here that might help. Now, so the green, can't see it. The green one, I believe, is this one here. Let's see if we turn this right upside down and get it the way it is. So this would be number 2. See, I may not be holding this correctly. I don't know if the coils are between here or between here again. I think they're between here. Should be a giveaway if the color of these wires is noted on the schematic, which I don't think it is, or I can figure out where these wires are going. So there's only one wire here and one wire here. The others have multiple wires. 2 terminals with 1 wire. 2 terminals with 1 wire. Let's look at the schematic again. 2 terminals with 1 wire. Oh, look, it is labeled blue. Blue. So this is going back to the plate, back way over here. So that's blue. And did they write a color on here? They did not write a color on here. Although look down here, that it's red. So we have blue, and then no color here, and no color written there. But we know the number of connections. So we know there's 1 connection here, 1 connection here, multiple connections potentially here. And I can spot this resistor too and kind of sort this out. Okay, there's enough here to go on, especially this blue. Let's start with the blue. So I'm going to look back at the radio here. Where's the blue wire? So here's a blue wire. No, here. This is the blue wire. Put some better light on it. This is the blue wire by itself. So I'm just going to look back at the schematic on my own. So the blue wire is connected to the B plus. So you would assume a B plus traveling from here to here. B plus is the terminal with a, I assume red wire, and many things connected to it, including a capacitor to ground, right? And there's also an electrolytic capacitor involved in there too, but may not appear. There's one right here. Do you think this is a ground terminal? Capacitor, and there's a resistor. This capacitor and this resistor appear to be just in parallel right here. And this resistor's value is, looks like red, yellow, green. Red, yellow, green. That would be 20, 24? That's a weird number. 20, 24, 2.4 megohms. It's kind of a weird value. 1K, 1K. 1K. So the 1K is over here. No. Here. 1K here. What am I doing? I got myself turned around. Didn't I? I did. That's okay. That's the whole idea, is keep turning around until finally I'm facing the right direction here. So we've got B plus coming in here, and I've forgotten already. And the blue is going, this is going up to the plate of the previous tube. So this is the high voltage circuit. So we expect the high voltage to appear here, not here. So this would be the other side of the coin. The other side of the coin now should have a wire on one lead, and it should be going right up to a, potentially this is the grid on the output tube? I believe so. So, and in this capacitor and resistor, there's a 2.7 meg resistor with a capacitor in parallel. There it is right there. So that identifies this as the grid side. Plate side, grid side. High voltage, no high voltage. Let's do the high voltage test and find out if this is really true. Okay, I'm going to get things set up to do that. The low voltage, high voltage test. Okay, so I'm looking into the question of feeding in the B plus. I'm already got my B plus supply leads ready to go. Where to clip them? I thought, oh, I'll just look at the filter capacitor and just kind of clip it there. And I took a look. Oh, too many wires connecting there. The capacitor is isolated from the chassis, so it's not just a simple matter. And it looks like, when I look at the schematic, that B plus is intimately involved with the heater string. So let's take a look at that on the schematic. What that would mean is, if I'm fooling around here and injecting B plus, I could be, again, injecting it into the heater string inappropriately and burn out a bunch of fragile tubes. So I'm really quite anxious about this. Let's look at the schematic for a bit here. So down here is the heater string. It ends here. Let me just expand this a wee bit. And it starts way down here, right from the plug. Ballast adapter socket. Ballast adapter. I don't think this has anything to do with this radio. So we're going through, and you can see here's the rectifier, and here's a big filter capacitor now. So we've got some B plus type voltage here. And where does it go? Seems to carry on along through here, and eventually it's going through the heaters. 25 volts. That's probably the rating. This is probably the rating here. Yikes, that makes all these resistors very critical in making sure you've got the right tube voltages spread through here. Yikes. Okay, but it also means if I took the filter capacitor, there's a leg here, and feed power across here, I'm also feeding it down here. Now if I'm playing around with just 10 volts, surely that's not going to cause a disaster, but I couldn't figure out which terminal on the capacitor is the grounded terminal. the B minus terminals. I shouldn't say grounded, the B minus terminal. See, the only thing that ties to the chassis is something with this kind of symbol on it. The rest of them, these things, is tying to just a circuit wire, if you like. And the reason I'm really shy about this is because I have worked on a radio not of this exact sort, but something similar with the low voltage battery tubes, and it blew the heaters in a whole set of tubes, 5 tubes all at once. Didn't even know it had happened. So at the time, didn't know it had happened. Very high anxiety situation. So another way to do this would be to bring the radio up, like plug it in, crank down the supply voltage way down, and slowly bring it up. And watch carefully what's happening on, it would be the grid, of what would indicate something's going wrong. No B plus showing up here. B plus showing up over here. These are denoted by terminals on tubes. I don't have to worry about me thinking through this properly. I mean, I haven't. That's the whole problem, is I may not have thought through this, so I'm just leaving this out of the picture. I can take a look at pin, and they're numbered here, pin 6 on the 1U4, or pin 2 on the 1L6. To monitor these two things, start the radio up, plugged in, bring the voltage up slowly, and watch what happens. This one should go up, and this one should not. Now, would that be enough to prove the situation? Probably is. Probably is. So I have to set up for this. We want to monitor these two voltages simultaneously and bring up the voltage. Just call me Mr. Cautious here. Okay, took me quite a while to find the B, safe or certain B minus point. This capacitor is the one that ties the B minus circuit to the chassis. It's soldered to the chassis right here. Has this resistor paralleling it. This is the B minus point here. These two terminals are tied together. That's a big fat B minus point jumping right out of the radio. I need that to make voltage readings. Here. Okay, we'll put this on the negative here. Isn't that right, Bert? It's a lovely sunny day outside. What am I doing in here? I gotta get out of here quick. Okay, but rushing is part of the formula of making mistakes and having accidents. So I don't really want to rush here. Okay, now what I'm planning on doing, looking on the voltmeter. He's going for the microphone. Okay, here he goes. Here he goes. Why do you do this, bro? Like, what's the big deal about this? What for? Oh my gosh. Hey, come on. You're getting bigger and stronger all the time. And you're causing bigger and stronger problems. Look, you're going to knock the equipment down and everything. Buddy, you're just too big for this. Come down. Come down. I'm going to throw the green lid. Ready? Hey, see the green lid? This is going down the hall. You see it? You're watching it? Here it goes, down the hall. No, it wasn't good enough for him. How about this? Look at this. This is a fake mouse. Hey, here. Hey, fake mouse. You want to chase that? What do you say? Here you go. Go, man, go. No, don't look at me. Go. How do accidents happen? Well, here's one. There he is. Okay, little kitty. Those are my grandparents in the background there watching me. Okay, you need a little petting. I'll give you a little bit of petting. I gotta go back to work. Oh, that's the coffee machine giving up. Okay, I'm putting you down on the ground. Now you go chase those things I threw down there. In fact, I'm closing the door, you're not coming back in. Okay, here we go. Back to this situation. So my plan will be, I think the B plus is coming in here. I think it's on the other side here, heading out to the plate. So this is grid, bottom of the grid transformer, if I can call it that, and this is the grid connection here. No voltage appearing here, all voltage appearing here. That's the plan. Okay, now we're going to crank down the supply voltage way down. Never had it that low. That's way down. I still have the dim bulbs in the circuit too. I'm going to plug it in. Now running radios on low voltage is not the best thing for a radio. If you run tubes with a low heater voltage, there is a range of temperature you do not want to enter with certainly some tubes anyway. So just reducing the voltage, you might think, well, it just relaxes everything, but it actually creates a state that's very bad for the cathode. I believe that's the case. In the short term, it won't matter. Let's get this camera out of here, so it's not in any way involved. Get my lead in my hand. Okay, so according to this meter, we are going to be starting up with 20 supply volts coming at this radio. So I should be able to find the 20 volts pretty much. Maybe not here, maybe reduced a fair bit. We will see what it is. This is the place to start though. Okay, let's do the thing here. Here we go. Watch that meter. Yeah. Okay, so there's a voltage there, about 15. And we should find it here. I'll find it here. It's from here to here. Well, that's okay. That's right. That's correct, isn't it? What was the blue wire? What was the blue? The blue wire. I can't remember now. Yeah, the blue wire went to the plate of the. I'm just checking here to make sure. Yeah, blue wire goes to the plate. Thumbs up. So we have. Let's turn it back on. So we have plate voltage appearing on what appears to be the primary side of the transformer. On the secondary side, we have a lovely 0 showing up. Lovely. All you gotta do is just crank this voltage up and the radio should start working. He says. Let's turn it off. Take this off. Plug the loop antenna back in. Okay. Do we want to keep an eye on this for some reason? Why would we want to keep an eye on that? If it's going to smoke, the smoke's going to come out the top. So, so let's flip it up this way. Here. Can's a bit of an angle. Okay. Spin the radio around. Here. I've still got my scope connected. That's okay though. It's just on the speaker. Won't hurt anything. Okay. Tuning volume. I want the volume up. I'm slowly bringing the voltage up. We're going to want to hear the radio as soon as possible. We want to be on the broadcast band. I'm not sure what band we're on anymore. That looks like a limit. That would be the broadcast band. That would bring this into the broadcast band. speaker. There's no, what am I talking about? It's right here. What am I talking about? I've seen too many radios in my day. Get them all mixed up in my head. Okay, so we're ready again. Volume up. And tuning down this way. Stations maybe in this area. I'm going to set up the antenna booster. Here I have to go throw a switch because we really want a signal, right away. We need the assurance real quick. So I'm going to go drink some coffee now. Okay. I find that these critical moments here, I tend to delay them and postpone them. Look for excuses to not find out that things don't work. Let's find out if they do or not. So again, volume is up. This might come on pretty loud right away, but so let me just close my door here. Okay. No, it's not going to come on loud because I'm going to be ramping up the voltage slowly, so that's not going to happen. That's not going to happen. Here we go. Okay, I think it's on. I'd have to get out my voltmeter to find out. Here we go. So I'm going to raise the supply voltage here. Jump it up a fair bit. Anybody hear anything at all? Oh. Thank you, meter. Not quite what I'm looking for. Let's hear if there's any clicking. Nothing. Okay. We're gonna go a little higher here. Okay. Oh, oh, oh. I hear a radio. Let's tune it. Wow, isn't that something? It's making sound. Band change. Of course, it can be tuned way out, so we would need a very powerful signal to break through. Down here. So its operation is absolutely consistent, so if something was going to burn out, it would have done it by now. We get nothing. We get nothing. Let's try some other bands. On my Hammerland, there's a particular capacitor that if it shorts out, your radio goes dead. And if you start switching bands, you burn out a component in the band. In every band you check, you'll burn out a component. I don't think that's the case here. Okay, so we're going to stop here because it's a good place to stop. The radio appears to be operating, and I think that's good enough for today. Wow, really quite nervous. Quite nervous about doing stuff like this. If this was my own radio, I wouldn't be that nervous. It's somebody else's radio, so I don't want to mess it up. Okay, I'm going to leave it here. Tomorrow we will pursue trying to do an IF alignment. We'll discover then if what I've done really did work out or not. Hey, thanks a lot for watching. I'm going out to enjoy the sunshine. See ya.